Let's take a look at a DC to DC buck converter. So we have a switch here. I'm using a 2N7000 MOSFET, and I'm just using a pulse width modulation to turn that on and off. Then we have a diode here. This is acting like a switch. You could use a MOSFET here instead, but this is going to be off when it's reverse bias and on when it's forward bias. Then we have our inductor. We have a capacitor to store some energy, and then we have a 330 ohm load. Now I want to put 10 volts in and get 5 volts out. Now, this circuit is just for demonstration. I wouldn't try to charge my cell phone or anything with it. What they would do on a real one, they would put, you monitor the 5 volts, and if that 5 volts happens to change because of load or whatever, then we could change the pulse rate going in to increase or decrease the voltage there. But in this case, we're just going to see if we get our 10 volts in and 5 volts out. So what happens here is that when we turn the switch on, this here we put a pulse in there, turn it on. We put voltage across the inductor, and that's going to be equal to V in minus V out across the inductor. And when you put voltage across the inductor, the current's going to start to rise up, and it rises in a linear fashion. So inductor opposes the rate of change of current flowing through it. Now, this slope here is determined by the inductance in henries divided into the voltage, and that's the rate of rise, and it's going to be in amps per second. But it's going to rise up, and then before it gets too high, we're going to open up the circuit here. Now, the field around the inductor is going to collapse. I'm just using one of these little, this is a 1/2 watt inductor, and this side here is going to be more negative than this side, and that means current's going to flow through the diode here, through the inductor, and then through the load. And that current's going to drop off with this slope here, okay, as this voltage starts to decay. Now, that means that the current over here is going to be twice the current here. If we put 10 milliamps in here, we're going to get 20 out here. And that makes sense because we have 10 volts here and 5 volts out here. So that's how the system's going to work. Now we want to determine the inductance here. And I'm using the formula from Texas Instruments. And so the inductance in henries is going to be equal to the output voltage times the input voltage minus the output voltage. And then we divide that by the ripple times the frequency times the input voltage. And the frequency I'm using is 30 kilohertz. Now, for the ripple, I was guessing at the ripple to be about 10% because I don't have much filter out here. I just have a 100 microfarad capacitor. And so if I calculate that out, it comes out that I need a 830 microhenry inductor. Now I have a 1 millihenry, which is 1,000 microhenry. And so I'm going with a 1 millihenry inductor. Now, what I did do though is I put it on the scope to see what I actually had for a ripple. Now, when you put it on the scope, I AC coupled it so that I don't have any DC in here at all. This is just the AC. And that happens, the RMS value of that happens to be 413 millivolts. So that works out to about 8.25% a ripple. So if I actually use that figure in here and divide that out, it comes out to a 1 millihenry inductor. So this is going to work out just fine. So that's all there's to the circuit. I have one right here set up, and we'll see how it's working there. Now, I've got this is 30K here, and I got 10 volts in, and on the output I have, I don't know if you can see that, I have 5 volts, 5.24 volts output. Now, in order to change the output, you can change the duty cycle, and let's see if I can do that. Oh, it's going up. Let's do it the other direction. Oh. There we go. That's about as close as I can get it. So that's the duty cycle's at 45% now. But you can change the voltage with the duty cycle on there. That's a good way to adjust the output voltage. But that's all there is to it. I'm getting 10 volts in, 5 volts out at 30K on my little inductor there, my 1 millihenry inductor. But that's just a simple DC to DC buck converter. Now I wouldn't use this on any cell phone or anything like that. This voltage out here isn't going to be stable. If you change the load, this is going to change. So on a real circuit, you would monitor this output voltage and then maybe change the duty cycle to compensate for the output voltage to keep it steady. But and there's chips to do that with. But in this case, this is just a fun little circuit to try out for a DC to DC buck converter. Thank you.